No, it looks like we're live.
Oh, okay.
Yeah, all good. Okay. Should we share the blog post?
I think we can say hi to people in the meantime.
Oh, yeah, let's do that.
Hi, everyone.
Focus here.
I think we are live. Let us know if you can hear us, if you can see us. In the meantime, you can tell us in the chat who you are, where you're watching us from. You can tell us what is the temperature like where you are, and we can all compare the notes as we wait for people to join.
And there's Johan.
Amazing. I can see some delay quite pronounced on YouTube, but I suppose it's expected, right? Maybe like 10, 20 seconds.
Yeah.
Good.
What is lag G? Oh, it is my camera, right? Oh, maybe I can figure out how to swap my camera. Mirror camera. This is better.
Oh, wow. Hello from Burkina Faso. That's nice.
Ooh, yeah. Rookie mistake, Johan. I fixed it. There's Olya. The GraalVM team is watching us too.
Yes. Okay, maybe as people are tuning in, we can slowly start because we have a lot of ground to cover, right?
Yes, I just shared your screen.
Thank you, Fabio, for bringing up our screen. We have a slightly different setup today, so give us some sort of patience for any sort of disruptions we might occur in the stream, but we hope it will go smooth. So hi, everyone, and welcome to the GraalVM 25.1 release stream. We have a brand new release for you with a lot of cool updates, so many that we are not even sure we can share them in 1 hour, but we will try our best. And there is so much that we want to tell you. But before we do, we want to explain about our releases, what is this 25.1 release, and what you can expect from us moving forward with the new GraalVM releases. Right, Fabio?
Yes, I'm already responding to questions in the comments.
Amazing. Teamwork. So I will let, in the meantime, Fabio cover the questions, although, yes, the stream will be recorded. That is luckily managed for us by YouTube and Restream, we hope. So we hope it will go smooth. In the meantime, I will start telling you about our new release. So today we are releasing GraalVM 25.1, and it's our first innovation release. Now, what does it mean? Because GraalVM has always been very innovative, but moving forward, we will have two sort of kinds of releases. We will have those innovation releases. The first example is 25.1, and they bring actual innovations and new features. So in every such innovation release, you can expect new features. They will be freshly built from the main. So all the latest features that we have been developing will be available immediately to you in those innovation releases that we will release on monthly schedule. In the meantime, we understand that we also have a lot of users who use maybe GraalVM stably in production, and they value maybe a bit more than those new features, this stability and expected behavior from the GraalVM runtime. And for those users, we still maintain the stable GraalVM 25.0 baseline. So you can choose either you want to test the latest features released as they are released with innovation releases, or you can stay on this stable sort of production grade baseline with 25.0 baseline. And we have an entire blog post covering all the questions that you might have related to our new sort of release cadence. You can read more in this blog post that is also on our Medium. What you need to remember is that we will have innovation releases that will be marked as 25.1, .2, .3, etc. Or you can choose to receive just CPU critical patch updates on the 25.0 baseline.
Yeah, and we accelerated the release trains because we feel like AI has changed the way we operate, right? And we want to be able to deliver features more frequently. At the same time, we know that a lot of you are staying on LTS releases and don't want to update or cannot build your app with newer JDK releases. So we're staying on 25 for now, but the plan is, of course, to move to the next LTS when it comes out. But for now, we are delivering new features based on 25, which is what most of you are using.
Right. So this was about the sort of setup, and now let's look into this actual release, and we can already sort of see as a teaser the first big update we want to talk about. By the way, this is our release blog post, and just before the release stream, I published it, so you can also read it at your own sort of pace and convenience offline, but we will walk with you through our sort of highlights and favorite features and show you some demos to back them up. Now, this first feature and update that we want to talk about will be related to the size of native images. Now, native images are already known and I would say widely used as sort of compact deployments because native images, as we know, due to our very sophisticated static analysis along with very powerful optimizations coming from our amazing Graal compiler, they already produced very small artifacts that are very compact. So they're easy to deploy, easy to scale, and that's something that many of our users appreciate about native image. But the sky is the limit. So in this release, we are further reducing the image size, and we did measurements across a wide set of benchmarks that we run internally. And what we see is, as always, the exact impact differs depending on the workload. But the sort of baseline update that we see on our benchmarks is that you can expect around 3% smaller images across a wide set of benchmarks. And then there is a set of apps, a category of apps that benefits the most. And those will be maybe small applications, things like CLI tools. Maybe you have some sort of automation build tool that you are using and you have built it with native image. So those kind of tools will see even higher impact and they will become even smaller in this release. And there is a number of improvements that got into the release. You can read more in our release notes or change log, but what you need to know related to specifically this image size reduction is that it came from a better string.format optimization, and also it came from the way we organize image heap in your native image application, and also how we reduce the metadata in this native image.
Yeah, and string formatting makes a lot of stuff reachable in the app, so that keeps your base cost really high, and that's one of many reasons why Hello World is comparably big. But because now that we have this optimization, we can actually get the base cost down. So especially Hello World has reduced significantly in file size, right, Alina? That has 2x or like size, right?
Numbers. So on my Linux instance that I will be using for demos today, I will not show a Hello World. I will show something a bit more complex, but a Hello World, as Fabio mentions, the impact is very significant. And specifically on my machine, I went down from 13 megs with the previous GraalVM version to just 6.5 megs with 25.1. So that is exactly 50% image reduction size with 25.1 out of the box without any additional manual tuning from my side. Okay, and here in the blog post, we quote some numbers that I have measured to show you the impact of this optimization, but I would actually like to show it to you live as a demo. And as I bring up my demo screen, you can also tell us in the comments, what is your favorite sort of aspect of native image? Do you use it mostly for startup times or image size or memory saving? So what is your favorite sort of aspect of using native image? And as you hopefully tell us, I will bring my screen and I will just go to the correct folder, which will be this Google Java format. So this will be our first demo. And as the name suggests, this will be the project that is a Java formatter from Google. And the name, I think, is self-explanatory, but let's look at it on GitHub. So here I am in releases, and when I just open the actual project, it's a formatter that will format your maybe not so pretty Java source code according to Google's coding conventions. And what I like about it the most, alongside of it being a useful tool, as someone working on GraalVM, I like that they're using GraalVM and namely native image in its releases. So when we look inside the GitHub workflows, we will find in the release workflow, but similar in the CI workflow, that they're using GraalVM, and namely 25 edition, to produce their releases for distribution. And when we look here at the actual releases they are making, so the last release was released in March already on GraalVM 25. And I see here both jars and native executables coming from native image. So this is a good use case of native image to build those platform-specific, extremely compact native executables.
Yeah, and here startup really matters, right? Because typically in your IDE, you set up a formatter as some sort of on-safe action, and you don't want to wait seconds until your Java code is formatted. So with a native image, you profit from fast startup and really low memory consumption, and you get really snappy feedback while you're in your IDE using the Java formatter.
Right. So now we also know what Fabio likes the most about native image. That's good to know. So what I did with this project, I just cloned it from GitHub. And because I have the latest GraalVM version available here, I built it myself. So I have GraalVM CE 25.1 because I had an early access build, but it's also becoming available to you as we speak. So what I did, I rebuilt this project from scratch myself with this latest GraalVM. And let's see what I got out of it. So I see for my sort of core project distribution, I have in my target directory a compiled native executable that I have built myself. And we see that it's indeed a native executable file built with native image. And now as I run it, I can see what it does. So it prints a help file for me. I can understand what I can do with it. But to just see a little bit of it in action, I will copy this demo command to reduce for myself typing and mistyping. And now when I pass to it this not so pretty Java source file and ask it to format, and I pass it to my freshly compiled native executable, it will print it out in a much sort of proper format as it should be. So we see that the application is actually running and it's built correctly and it is a native image. What about the size though? So we started this conversation with the size. This is my native executable that I have built myself here from scratch, having 25.1 available to me. And this is, I just pulled their official release for my platform that has been built before and already released. I would imagine this was built with 25.0 something, so with this stable baseline. And in my release, I can see that in my version, it is, I would say, 3 max smaller, which on the size of this already very small utility built with native image, this adds up to 7% almost reduction size, which I would say is a very good improvement out of the box without additional tuning, but also specifically for this sort of CLI tools that this way are nicer to distribute because they are smaller. And also those image size reductions will translate to some extent to even memory savings. So if you're building tools that you distribute with native image, if you're building native executables, and specifically if you care about image size, give a try to GraalVM 25.1. We have some good optimizations already available for you out of the box. And then in the next releases, we're already working on the next releases. We are preparing even more optimizations of image size for you. Okay, we talked about image size improvements. As I said, the exact sort of impact you will see on your workload will differ. So do try on your own workload and let us know how it worked for you. But we can expect image size reduction across the board. Now, the next topic that I want to talk about related to native image is one of my favorite ones, and that is native image performance. And in this release, we have one of the features that was highly anticipated by me, definitely, and I know that by many users in our community as well. And that is that our G1 GC in GraalVM native image is now coming to Darwin. And that's a great improvement, for example, for someone like me who maybe develops every day on their Mac machine, but they also have a deployment environment that is Linux-based. So in my case, all the demos that I show are running on Linux. And in general, this is my development workflow where I have my Mac as a sort of physical local machine, but also a Linux remote instance. And with this change, this means that I can have the exact same setup on my Mac and on my Linux. And it is important for me because I often talk about native image performance and I showcase performance demos. And what I often use there is a sort of Maven profile where I have all the best optimizations in one place that is PGO, G1 GC, MARC native, and this means that I can have the exact same setup and same Maven build profile for my Linux and for my Mac. So this one I'm very excited about, but also aside from this sort of remote dev and CI like improvements that this brings, also if you build your app specifically for Darwin, you can obviously expect a better performance coming from G1 GC.
Yeah, and this is especially useful, for example, also UI applications that you want to run on Darwin, right? And yeah, we are embracing the whole new AI world, and they make us more productive and help us do these things that we always wanted to do, right? So G1 runs on more platforms, and maybe soon we'll add another platform too.
What is that mysterious other platform? We can all guess, but I think
I have the feeling that I'll meet you again in a month, so we'll talk about that maybe soon, right?
I think so. Okay, and in a similar space of sort of native image performance and GC performance, our sort of default GC or native image, that is serial GC, got a new policy that is called adaptive 2. And we expect this to be particularly beneficial for reducing the peak RSS of your application, but similarly, in many cases, also throughput and latency. Mainly, though, it does target peak RSS. So if your application has been experiencing higher maybe than you would wish peak RSS before, with this new policy in place, we are fairly confident that it can reduce those sort of like peak spikes. And we like benchmarks, we like having facts to back up our statements. So in this case, we used a Micronaut shop cart application, and we measured the impact of this new policy on that application. And our benchmark shows that we got 8% lower peak RSS and even almost 4% higher throughput, which is also a nice addition. Now, I think we would need to speed up because I noticed that I'm talking so slowly and relaxed, but we only have 1 hour, so let's see if we can slowly speed up. Now, the next topic is, again, one of the ones that I like quite a bit. So you might know that native image does sometimes need configuration for those more dynamic Java features. We all have probably faced this in one way or another as we build our applications. But to sort of help and solve maybe configuration issues for common libraries, we have created quite a while ago this centralized repo that we have on GitHub, where we thought, why would our users need to figure out libraries on their own if we can just create a centralized repo? So think maybe like Maven Central, but for native image configuration, where we can contain this configuration for many and many libraries. And we had created this repo long ago. I think looking at here, we can see that it was years and years ago. And together with our community, we have built out this repo to contain configuration for many, many libraries in the native image space. But as you can imagine, maintaining this repo, keeping it up to date, and keeping sort of in check with all the libraries and updates and new versions that they introduce is not a simple task. But luckily, AI came into our world and got to the sort of production-ready state. And we have utilized a fleet of many, many AI agents to produce configuration for many, many popular Java libraries. And I will show you my favorite page that you can use to check for your library if it is native image friendly. You might have noticed if you check this page maybe at some point in the past that it got significantly longer because our team, with the help of AI agents, added configuration for almost 1.5K libraries in the GraalVM space. And if I want to look here, for, let's say, for something maybe Micronaut related, I will find somewhere here a fleet of many sort of Micronaut modules at configuration that is provided for them from our repository or from the library itself. So now if you want to use more libraries with native image, it just got much simpler. And I want to quickly show if I can figure this out. I think I can. If you have, actually I think we have it in the README. So if you do stumble upon a library that is not covered by our 1.5K thousand configuration for libraries, what to do in that case, you can just click request new library. And then the only thing you need to do is pass the Maven coordinates so we can ID your library. And then you can provide some additional context, but it's not really necessary. Just give us the Maven coordinates and we will take care of that library. And we also have a talk from DevOps UK coming up on YouTube where you can learn everything about it and how our team implemented. So we are also waiting for it now.
Yeah, shout out to Voin and the team. I think we can all agree that AI is great at writing tests. So in case you're wondering how this works, like we are generating a test, and then the agent will, use the trace agent to gather the data. So it's not going to like hallucinate the data, but it's actually going to run the thing and collect reachability metadata. Correct me if I'm wrong, Alina, but that's how this works, right?
Yes, that's how it works. And from my experience, I have reported those libraries in the past. So it's actually quite interesting because then you get updates from GitHub saying, agent is on it. Then if it stumbles into something complicated, it asks a human for a review, but eventually it figures it out. And there is sort of a process to handle even more complicated cases to make sure that we can take care of your library and your request. Okay, so that was about the power of AI, and here you can.
Well, not just for us, right? We want to share what we can do with the community, and AI can also be used by the community, right? So that's the cliffhanger to the next section, I guess. You almost forgot about that, right?
No. I was about to go there, but then I saw this beautiful chart.
Oh, right. Oh, you forgot about the chart, right?
So if you can see, this is our libraries and our coverage over time with this reachability repository. We did a lot of work manually, but as you can imagine, it is a lot of work indeed for a human to do. And now with the introduction of AI, I think it's one of the most sort of useful use cases of AI that I saw in the wild so far. Now we have all those libraries covered. But Fabio was setting me up to talk about this next topic. And as you can tell, we have embraced AI quite a bit in the Graal team. And the next topic on the agenda is that we have a new native image skill for you and for your AI agents. Before I talk about this, I will just quickly give a shout out to this whole repo. So there is a repository on GitHub called Oracle Skills, the official centralized Oracle repo for AI skills for many different technologies. You can see here Graal, obviously. You can see Oracle Database, Oracle Apex, Fusion, OCI. And from here, you can get all those skills for all those various technologies. Obviously, we encourage you to pull the Graal skill, but also check out the other skills based on what you are using and make sure that you gave them a try. And we work on our skill to make sure that it can give you some what we think is best practices for building native image applications, testing them, optimizing for various aspects. So all of that is in the skill. And here you can do two things. You can either go and explore it on GitHub, such as we are doing here now, or you can just install our skills and use it for your projects. And then you can tell us how it went, if you like our skill, and you can even contribute to our skills if you think there is some interesting feature missing. Now, with that, I would like to talk, I know I said it a lot, but one of my other favorite native image features in this release, and that will be the dynamic class loading in native image. So here we just have some random medium banner, ignore that. But what's with dynamic class loading in native image and why would we need it? So as we know, we build native image ahead of time. And as we build native image, it can apply very powerful optimizations. But because we build it ahead of time, pretty much everything there is to know about your application needs to be known at build time and needs to be available at build time. And native image is quite smart. It can sort of detect and infer a lot about your application, but not everything. And especially in the past, it sort of was not possible to load new classes into a running native image. And this was a bit of an issue for specifically libraries that maybe want to load or generate new classes as your application actually runs. And towards sort of like removing that limitation, we've been working on adding a capability to load dynamically new classes into a running native image. And this is something that I will show you today. And I will show you an example of an application that will be a Micronaut app using ByteBuddy. So if you've been following our project or ByteBuddy in the past, you would know that there was a bit of a sort of complicated relationship between native image builds and ByteBuddy. But hopefully with this dynamic class loading, this will be sort of reduced and less of an issue moving forward. So let me see if I can demo this for you. And this is all leading edge.
For those of you who don't know, I think ByteBuddy is used for testing, but at least it generates JVM bytecode at runtime, which of course you cannot. Which you cannot use in a native image because a native image consists of machine code, right? So there's no more JVM bytecode. But with this new dynamic class loading feature, we can actually make that work, right? So.
Let's see. So I have here a Micronaut application. We see here that it's a Micronaut app, and it takes as an input a sort of plugin or a configuration file that we have defined here under plugins conference properties. So let's say the application is some sort of, I don't know, conference app that prints who is speaking and where for social media, or how conferences have those agenda walls where you can learn who is speaking and where and at what time, etc. So we have an application that sort of emulates that. The interesting part is that it takes that plugin file as sort of configuration when it runs, and then we have a little bit of a domain model sort of defined here, where our key entities are the name of the conference, location, and the speaker who speaks there. And then we have this greeting factory that is utilizing ByteBuddy to generate new classes on the go as our application runs. And you will see that hopefully in the demo where the class name will be printed, because you will create new class using ByteBuddy. We will append a timestamp to show that this class is actually new and it's a new class every time we run demos again, hopefully. And then we will have constructed sort of message based on that configuration file that we will be able to change. Now, let me see how this works. So this is a normal Java app. At the moment, it's a Micronaut app, and the moment we can run it with the JVM, I will just pass my little hook to pick up the conference file. And it says, all good. This is our Micronaut context. This is our generated class with a timestamp. And it says that Thomas is speaking at Davos, Morocco, and he will talk about what's new in GraalVM. Let's introduce some changes to our file, though. So let's say the speaker now will be not Thomas, but maybe me, and I'm speaking maybe not in Morocco, but in Belgium. And let's see if this runs again and if you can see the change. Okay, so it says, hello from Alina at Davos, Belgium, and we did not add the message. That stays the same, but we do notice that the class name is different. So it was a different class generated and provided to us by ByteBuddy. Now, we are in the GraalVM release stream, so probably there is some native image coming up somewhere around the corner. So let's take a look. Here I have my Micronaut ByteBuddy dynamic native image. The name sort of tells what we can expect from the file, and we see that it's indeed a native executable. So let's run that file target, and I pass my native executable, and again, I just pass a little hook to my conference properties file. So now it says that it's Alina and she's speaking at Davos, Belgium. And let's just introduce some change so we can have a new class. And let's say that maybe Fabio, wrong typing. So maybe Fabio is now the speaker. And let's say that he is speaking in Zurich. Okay, this is saved. And now when we run again, I'm running native image. So I hope this part is sort of like clear and is coming across that it is a native image running, but it does see that now the configuration and the plugin that we are using is defining Fabio as a speaker, and then Zurich is the conference location. And we see that the class that was generated for us on the go by ByteBuddy, it has a different name. So it is a brand new class generated on the go. Now, my demo is fairly minimal, but I do hope that it gets across this point that you can load new classes into a running native image. And this might be a small step for sort of native image, but a huge step for humanity, because loading new classes into native image is something that many of us have been waiting since forever. And it opens the door for many, many even new use cases to native image. So I'm very excited about this feature.
Yeah, Johan correctly pointed out that some folks are also using ByteBuddy for Lombok. But even if you don't use ByteBuddy or class file API, which I think is also like doing something similar, you would like maybe even benefit in the future from this because, for example, we could do something like a native Maven, right? So the Maven daemon is already a native image, but we can compile Maven itself into a native image. We haven't done so far because a lot of people use plugins, right? And the plugins extend Maven. But with this, we could potentially load Maven plugins that are also that are then dynamically loaded, right? So that's all very excited. That will improve your Maven experience or Gradle experience. We could do the same with Gradle. But this is also a prerequisite to what we actually want to achieve, right? So that's the hook to go back to the blog post, I guess.
Yes, so this will be one of the building blocks for our beloved project Krama, and Krama will actually introduce open world to native image. So it will eliminate or take away that previous closed world assumption and will open native image to even more and more opportunities and use cases. And while this is still sort of early version and work in progress, we are actively working on it. We will have updates for you in the next releases. But already in this release, even as we still work on these features, we already have a JIT compiler for runtime loaded classes, and we have a cool code name for it. I think we are quite good with code names, which is a very complicated program problem in computer science, but I think we're quite good at it. And Ristrato will add a JIT compiler to those dynamically loaded classes and already as it in this release. So as you can tell, we have a lot of great work that went into this release. And while specifically this dynamic class loading is still sort of something we are working on, you can already give it a try in your own applications.
Yeah. And this really means, like today you can choose between JIT or AOT, and you have to buy into one, and that's it. But with this, you can say, I want AOT, but I want this part of my application. For example, my business logic that I change a lot during development, I want that part to be dynamically loaded and JITted, right? So you can have the best of two worlds, and you can decide where you put the needle on the spectrum. And so that's the vision that we have.
So I see already questions popping up in the chat related to the dynamic class loading and the impact on performance. And more importantly, they're asking if we have any benchmarks or numbers to share or sort of idea on the performance impact of running versus on the JVM versus native image with Krama. Now, I would say from what I know, performance is still work in progress. Having a JIT compiler being available is a big step in that direction. I don't think we have any such numbers available already, but this is something we will be still working on, and Ristrato is already a good step in that direction.
Yeah, and we use the Graal JIT compiler, which is known to be a very good high-performance JIT compiler for JVM languages, right? So we know how to make that fast. With native image, I think we of course need to make some compromises, but you still get memory benefits out of this and startup benefits out of this for sure. And the file size may be a bit bigger because we need to compile in more into the base image, right? We need Java base to be available. I mean, the Java module to be available, because the application may, you may want to have that AOT compiled because you're not changing it. But we'll have to see. It's a bit too early to make good comparisons, but we only expect improvements here.
I like how excited our users are about this new feature. So we are just introducing it and people already expect performance, but fair enough. It's something that we are working, and you will get more updates in future releases. Now, as you know, we care about developer experience a lot, and there are a bunch of changes in this release related to developer experience in native image. We'll go through them quickly so that then we can switch to the next big section of this release stream, which will be related to our Graal languages. So we know we have a lot of Windows users, and they've been asking us for several features, and one of such features that they have been requesting arrived in this release. So in 25.1, we now have JFR recordings and heap dumps available on Windows, which we think will be greatly beneficial for people working with such native image applications on Windows, and specifically sort of tuning and debugging and trying to figure out what is going right or wrong with their applications. Now, we also added a new print options option for native image that you can get other build options available to you immediately in a variety of formats, such as table, markdown, JSON, etc. And probably you can see that some of those formats are more friendly towards AI agents. So I think that was one of the sort of reasons behind adding this variety of formats and this option. So now your agent can have a better understanding of what is available in native image and specifically in that specific release that you have. Now, as always, we did a number of updates to reachability metadata, improving your experience of working with applications and making them even more sort of polished and smooth, your experience with it. And then also we have portable native image bundles So bundles can now be portable across platforms. So depending on where you develop, where you deploy, you can now have a more sort of simplified and streamlined experience. And I'm just thinking what else could be interesting here. Treat warnings and errors could be useful in CI and sort of build environments. And I think with that, I can slowly wrap up the sort of native image section and give the stage more to Fabio for languages updates. But I will be back to talk about community and ecosystem updates for the whole project. So Fabio, take it away.
Yes. So let me switch our screens. Yeah, we can keep yours. So I'm on the same blog post, of course. So GraalPy has a lot of cool updates, which is our Python runtime. We now have JIT options that are supported also by CPython, so you can use these too. And they control the overhead that you get for JIT compilation, but also the throughput that you get out of this. So, for example, if you run a script, you don't want to run a short-living script, you don't want to run too much JITting, so you can tune that down and make sure that your application runs really fast and doesn't consume too much CPU and memory because it won't benefit too much from JITting. But if you run a long warning server for weeks, then you maybe want to turn on JIT compilation to a maximum so that you benefit from it the most and get really good throughput. Similarly, especially on native image standalones, we now have lower memory footprint thanks to the improvements in native image and the garbage collector, the new garbage collector policy that Alina already mentioned. We're using that now in GraalPy as well, and that has reduced RSS for many workloads and made GraalPy start up faster and use less memory. We're also working a lot on Java interoperability to make it really easy and smooth to exchange data types between Python and Java. We now have support for buffer-compatible binary objects, such as memory view and also Java's byte buffer and other types. For embedding use cases, we give you more control. There's a new feature in Truffle, our language implementation framework, to set source options, and we're now using them to implement a couple of GraalPy options. So, for example, you can choose the optimization level in a source and say this source needs to be optimized in that level, and this source can be used in a different level. Or you can say I want a new global when I run the script in this context. Stuff like that you can now do in GraalPy. Yeah, I'm running a little bit quicker through this because I still have a little demo prepared that I want to show, and time is limited. Compatibility is also something that is very important, of course, especially in the native world, because as many of you know, Python is pretty glue code between a lot of native code. And so GraalPy now has a new C API implementation, actually. For those of you who've been watching the project for a longer time, they know that we used to JIT compile LLVM bitcode to do native extensions in order to do sandboxing. But we're not doing that anymore. We're now using the Panama backend to do C API, and that has improved the C API performance quite a bit. So if you're using native extensions in GraalPy, that's now much faster. And also we have implemented a couple of new hooks like sys audit event hooks and so forth, which are also now available. Generally, GraalPy has made a lot of progress. It's now using under the hood a new bytecode interpreter, which is more efficient, and we keep adding optimizations to the bytecode interpreter to push its interpreter performance up and its memory footprint further down, while maintaining great peak performance. And that is true for all the Truffle languages that we're currently maintaining. So, and in terms of the standalone JVM artifacts, we have this one download for a platform that has a JVM included, so not a native image. So the JVM version of GraalPy, those were really big, and we didn't see too many users actually using them. So and because they are a pain for us to maintain, we have decided to remove them as a build as release artifacts. But for convenience, if you still want to run something on on the JVM directly or build a native image out of it, you can use JBang, which we really like. Shout out to Max. And you can just launch GraalPy using JBang as described here in this one command. That's the hello world. And you can then go and say, I want a native image out of it, and you can get a native image out of this. Okay, so that's it for GraalPy. For JS and WebAssembly, we have also some very good updates. So this is in this release, we're shipping ECMAScript 2026 by default with all the features implemented. And also we've updated Node to 24.14.1. So I'm really happy to see that we continue to make sure that GraalJS stays on top of the compatibility charts. And we also keep a close eye on ECMAScript proposals. So the temporal proposal is already implemented, which will likely going to ship with ECMAScript 2027. We've implemented a few new API hooks and made a few options stable. But in WebAssembly, we actually implemented the GC proposal. So that one I think is pretty big because you need this if you have WebAssembly code that needs a garbage collector and you want to reuse the garbage collector of the WebAssembly runtime. So if you have, for example, a Go application or Rust application that you compile to WebAssembly, they really benefit from reusing the garbage collector from the underlying WebAssembly runtime. And here we can use our serial GC or G1 GC. So that means we're making our GCs now available to the WebAssembly ecosystem, which I think is very exciting. And I can't wait to see more WASM GC workloads running on GraalVM.
The GC proposal that was, I think, highly anticipated by our community, and I was very happy to see it making it to this release. I just want to add to the GraalJS update for any of the GraalJS fans out there. We have a follow-up blog post talking about GraalJS 25.1 in great detail, as well as our work to stay up to date with the ECMAScript standards. So you can expect that next week maybe, and you can learn everything about GraalJS in this release from that blog post.
Yes, we have a couple of follow-up blog posts, and I forgot to mention that one. Thanks, Alina. So we also switched to a new bytecode handler-based interpreter, which is what GraalPy is also now using. So GraalVM is benefiting from all the work the compiler team is putting into our interpreters and make them go fast. Shout out to Yudi and Raphael, maybe. There's a blog post in the pipeline on that too, which I think is really cool. So I can't wait to see that published. And for WebAssembly, we have implemented a few more standardized features and turned them on by default. So if you want to learn more, click on the release notes button, which will take you to our release notes with lots of details. And for all the components, we have individual changelogs too, with with a lot more details than we have time for in this live stream. So now on to Truffle and our polyglot runtime. Truffle is our language implementation framework, and our polyglot runtime is what powers all of our languages. And I'm very excited that in this new or first innovation release, we're now shipping the Truffle Sandbox. The Truffle Sandbox is now available in Community Edition. So that means you can now, as someone who embeds JavaScript or WebAssembly, run any kind of JavaScript code and WebAssembly code securely in your embedding. That's something that was previously only available in Oracle GraalVM, but we now have an implementation in the Community Edition too.
And so, very excited update, and I already know at least a few people in the community who probably were waiting for this feature a lot and will make a great use of it.
Yeah, so this is actually here in the section you can see an example. So for example, if you now in this AI world, your users may use a lot of AI tools and really want to sandbox the AI written code, right? So with Truffle Sandbox, you can restrict what the user code can do with the host, with the file system, with sockets. You can cut off internet. You can disallow native calls. You can also set memory limits and say this can only run n seconds. Stuff like that is now possible in Truffle Community Edition. So I think this is where I should switch over to just a quick teaser that I want to show you. So yeah, we have an upcoming blog post, a technical blog post about the Truffle Sandbox, but we also have a new exciting project that yeah, we're going to release hopefully very soon. And I want to show you a quick demo of what that looks like. So this is using external AI components. So I really hope, yeah, pray to the demo gods. I really hope this works. So let's see. So you all know, I assume you all know Spring Pet Clinic. There is, of course, a Micronaut version, which I'd like to demo here. So this is Micronaut Pet Clinic. And Pet Clinic, you know, it has some owners. There are veterinarians. There are animals. So I can, for example, here on like Find Owners, I can search for owners. This is a demo reference app that you can see. That you can try out and see how to write applications in Micronaut or how to write applications in Spring, right? So there's a non-trivial application using a database in the background and so forth. So traditionally, like what some folks have done, for example, with GraalJS is you define in your application an interface that you want to expose as an extension endpoint to your end user, and then an end user can script your application. So that's what a lot of users are using GraalJS for example, or GraalPy, and in theory you could also do that with WebAssembly. But the problem here is that, of course, the consumer still needs to write code. Right, so that means like now I am a software developer, so I may be able to write some JavaScript code and configure Pet Clinic, but the pet doctor cannot write code, right? So let's assume I'm the pet doctor now, and I have a few things that I want to do in this application. So for example, here we can see all the pet owners, and we can see there's a couple of pet owners in Madison, right? So now I want to see only the owners and only their names that are in Madison and the telephone number, right? So now, well, you would say, well, that's just a SQL statement. Yeah, maybe right. But again, the pet doctor doesn't know how to write SQL necessarily, right? But what the pet doctor can do is the pet doctor can write a prompt. So in our project, which we call the Graal script agent, that's the upcoming project, we have a new tool that essentially allows, that automates the whole process. So what it does is it communicates the API that was previously exposed to the end user programmer, but it's now exposing the API to an LLM, and the LLM will use that to, respond to prompts. So that means not just I can, as a developer, can use AI to build an app, but now my users of the app can extend the app with plugins that are written with prompts, right? So let me give you an example. So if I click on Script Agent, we are now entering a chat mode, and you may want to do a chat, but you don't have to, right? And now I can write a prompt. For example, show all owners in Madison with a telephone number. So now when I submit this, our script agent will send the prompt to the LLM, and the LLM will know about the API that's exposed. And if all goes well, we can see the result. So these are the 4 owners in Madison and their telephone number, right? So note, I wrote human readable text. I didn't write a SQL statement. I didn't write code. The LLM wrote code. The LLM code is here. So we can see some JavaScript happening, and it has decided to use the owners API. Right, so this is indeed writing some JavaScript under the hood. Query only means the LLM has figured out, or the Graal script agent has figured out, that the API used by the LLM script only is read-only. So we immediately run it in the sandbox because it's not going to modify the data. The developer, the application developer of Pet Clinic, when they made the API available, they said that this API is readable and this API is writable, needs write access, right? So I can do this again. I can save the data as a JSON, but I can also just add this now, because this is what I want, to my owners page, right? So now I have extended Pet Clinic. I can go back to Pet Clinic and I can go and say, oh, here are my saved queries, and I can click on it and I can run it again, right? So I just modified my application with a prompt. Right? So let's see how far we can push this and learn a little bit more about this tool. what about adding stuff, right? So let's add John Doe, right? And what happens now is the LLM may decide, oh, well, this is now modifying data, so I need to do a different task, right? I don't query data, I now need to do a modification. So it has figured out that there is an endpoint in my app, which is called modification API add owners. So it can do that, but it has figured out this modifies data, so I need human approval to run it. So now when I run this and I go back here and I go here, I should have a John Doe in here, right? So this is our John Doe. Great, so that worked. Now let's do something even more fun. We can do add Homer Simpson as an owner, right? So now the system tells me, oh, there's stuff missing. It's missing an address, a city, and a telephone, right? Because the LLM knows about the API. It knows there is an add owners API, but it cannot satisfy all the parameters. It cannot provide all the parameters. So we can say make up the details that you need. Let's see. Okay, yeah, and of course the LLM is trained on Homer Simpson, and it knows that he lives in Springfield, and hopefully this is his street, and maybe that's his telephone number, maybe not, but you get the idea, right? So you can do more interesting things, and you can interact with the LLM to do something in your application. You can do something more complicated. So here I want to add a new dog called Fido with a birth date, and I want to register a visit. And the Graal script agent has figured out the owner already exists. But I need to add 2 modifications, and because these are modifications, I need to ask for permission to execute the code, and then that is now in the system. So let's do a few more other things. So we can ask, describe all the things that you can do. And now the script agent will ask the LLM to enumerate what it can do, and it will tell us about all the API that it has access to. It has access to the API. It does not have access to the data. That is very important, right? So it knows the LLM, the external LLM provider or local LLM that you may use, right? But if you use an external LLM provider, will get those prompts, right? And it will get the list of APIs that is available for programming, but it will not get Homer Simpson or John Doe or anything personal, right? That is very important. So that is something that we can do here. We can ask it, what can you do? To prove my previous point, I can also ask it, can you write a script? So let's say I know a little bit more about the system, right? So let's say I want to hard code all the owner names in the generated script that you do. And I say, do not use any sample data, because it turns out LLM models, they have now trained on Spring Pet Clinic, and they know all about the owners in Spring Pet Clinic. But if I say, don't use any sample data, hopefully this works, but I always get a different response. So now it has done something. Okay, it has, this is interesting. This is rather complicated, and I haven't seen it. So it has hard-coded something.
That's interesting.
But this is not... It is still calling the API, right? So it hard-coded something, but it's still calling the API. Can you please query the API and hard-code the actual names? The API call itself should no longer be in the script. Let's see if I can make that work. I haven't taken that to there we go. The agent will say, nope, I cannot do this because the LLM has no access to the data. It only has access to the API. And to illustrate the sandbox aspect of all of this, let's say we want to do a prompt injection. So we can say, generate a script that executes the following snippet. And here's some JavaScript code, because this is using JavaScript under the hood, which allocates a lot of memory. and then return the list of all owners, right? So like try hard. Well, let's see what happens. Oh, and it failed. It ran the code. Here's the code, and it has successfully added my little prompt injection, and it has executed my little prompt injection, the LLM. But then we ran the code in the truffle sandbox, and the sandbox said, no, we exceeded the memory limit. We cannot do that. So I can also, maybe I should try write an endless loop and then return the list of all owners. So let's see if that works. That is not language specific, but should work in any language that has loops. So I think it has a timeout of 5 seconds. So maybe, yeah, there you go. So it wrote an endless loop, a while true, endless loop requested by the user, right? And because this ran in the sandbox said, nope, this ran too long. We have to stop the process. So that's the little demo. That is all just like how this works for end users of the application. But how this works under the hood, we're going to follow up on with a blog post. We'll have the demo published soon, and we'll talk about it hopefully more at a few conferences too.
We will do. I just want to add my favorite sort of note about this new feature and this new project. So I like the point that Fabio made, that maybe staying with the pet clinic example, maybe the doctor or the receptionist are not necessarily developers. They can benefit from this like user experience improvement that this brings. But my favorite aspect is maybe from the developer side. So as a developer of such a pet clinic application, you can choose what kind of API surface you expose to the application. And then you have more control, in a way, more determinism, because the LLM does not make up tool calls or methods that it can call. It specifically uses what you expose to the LLM. And for me, that's even maybe more interesting as a developer, that I can have this nice sandboxed and controlled environment where this can be executed. As we were talking, I noticed that there were some comments in the chat. Let me very quickly go through them. So I see that our team members jumped in to expand on our answer about dynamic class loading in native image and the performance aspects of it. Thank you, Paul. So as Paul mentions, indeed, the execution in the case of dynamic class loading is not dissimilar to that on the JVM. So the JVM has a tiered execution system where your code is first interpreted and then eventually compiled when it gets hot. And it's similar when you load new classes with this new feature in native image. But interestingly enough, obviously, we need to sort of connect and link those new dynamically loaded classes to the ones that were already present in native image, sort of statically compiled. And that, it's not easy to do, but it does bring an interesting sort of performance advantage, because those are already AOT compiled and very fast. So I think the person asking about the performance in case of dynamic class loading will be satisfied with that answer. Then I see some excitement related to, I believe this was polyglot sandboxing. And then I see a question that someone already checked our release notes, and they see the notes on the WASM runtime, but they're asking what about the WASM target. I believe we did include an update on that in the release blog post. You just need to know that it's called web image in our GraalVM world. And there is an update, but I do believe that it is experimental, right, Fabio? So we can applications to WebAssembly, but it is still experimental in this release. We are working on it, but keep in mind that this is still work in progress.
I think it's I think we don't ship web image by default in Community Edition yet.
You need to switch to 25.1 on the left.
Oh, I'm sorry. Oh, then maybe our link is broken, huh? Here's a little, it's just this little entry. We haven't made any larger new features for web image. There are a couple of things that we did tweak, but in the last couple of weeks at least, we didn't prioritize it enough. The native image team is mostly busy with Project Kramer and other things. But one thing that I have recently showed is that you can now compile JVM languages with web image into a WASM module, and now you can run it on GraalVM too. So that required also some changes on web image. We haven't at all given up on web image. We just haven't prioritized it recently. Maybe we should make sure that we have some more updates very soon, Alina.
But also, I think I know of at least one cool internal project of a person developed something very nice with web image. So maybe we can ask them to share it and to write a blog post. And maybe next time we can share that work, because
Yes.
I think that was a very good use case of web image and something that we use internally at Oracle. So maybe we can ask them to write about it too.
There's already a lot of people asking us about it and how to use it, and we are we like to work with actual users and customers to be able to prioritize better. So if you do want to use it, feel free to reach out to us so that we can help you. But yeah, in this release, at least, we don't have any significant news to share about web image. So yeah, we're already over time. So let me quickly wrap this up.
I just wanted to talk about community updates. Okay.
Yeah, no, I was going to wrap up the truffle part and the polyglot runtime section, and then we do the community section. So one thing that we also decided to do is decouple truffle languages from the JDK. Standard JDK no longer support on 25.0, no longer run with just-in-time compilation, but Truffle and GraalPy, GraalJS, they all run on GraalVM 25.1 and later with JIT compilation enabled and runtime compilation enabled. If you are one of those users who are using standard JDKs down to JDK 21, you can now use polyglot isolates. That is also something that we are shipping with Community Edition now. So that's a native image that can be loaded into the JVM process and can be used to execute JavaScript, Python, and WebAssembly code. So you can use that with JIT compilation, or you can just use, if you want pure JVM, then you can use the fallback runtime on JDK 21 and later, but that's without runtime compilation. That's because all of this is because Truffle makes extensive use of JVM CI, and that is no longer being supported in the OpenJDK project, unfortunately. Yeah. So the JavaScript polyglot isolate, if you are using that, now includes WebAssembly support, so that you can use the JS WebAssembly API to call out the WebAssembly from JavaScript. And if you're using our standalone launchers, you no longer need to add polyglot. That's been removed and dropped because the standalone launcher no longer needs that. And yeah, if you want to find out more, check out the release notes. But now I'll give this speaker token back to Alina.
Thanks. Let me see if I can figure out in this new UI how to. Oh, okay.
I did it. It's fine.
Thank you. Let me just go back. Okay, community and ecosystem. We have some nice updates there. So I'm personally a big fan of seeing this GraalVM use cases, GraalVM being used in the wild, right? So real world organizations using GraalVM in many different capabilities. And I'm a big fan of those stories, but I also know that people always ask me at conferences to hear more about them and have some sort of way to learn about best practices from other people. And in this release, we have related a few content pieces that cover such stories. One that I like a lot was written by us in collaboration with Trivago, a huge travel sort of company and portal that are using native image to reduce the sort of CPU usage and the required resources to run their applications. So here we see that they went from having 43 replicas to just 12 for the exact same GraphQL gateway. And this is my probably favorite part of native image use cases, where people have the exact same workload running, doing the exact same job, bringing the same benefit to the company, but then they can use, in this case, I think it's 3x less resources to run the same workload. And it's a pretty sort of high load workload too, but I will not tease it for you. You can just click the link in our release blog post, and it's also on Medium, and you can find out about it more. In a similar fashion, but now going from native image back into sort of languages and Truffle world, our friends from Picnic in the Netherlands are using GraalVM in a very cool use case where they have their main sort of Java backend workload running, but also they have the team of analysts that are defining those sort of business logic rules to customize the behavior of the application. And those sort of analysts prefer working with languages such as JavaScript and Python. They are more proficient in those languages. So Picnic exposed a way for them to define those rules in JavaScript and Python, and then their Java application just picks them up. And this allows them to, well, bring those languages together smoothly. But I like to quote what the people working on this project said, that this allows them to iterate much faster, because in the past, those analysts needed to ask those Java developers, can you please introduce a rule that adds this or that? But now they can just introduce the rule by themselves and it gets picked up by the system. So that's a great use case of GraalVM and other languages.
And who knows, maybe they soon want to be able to prompt some rules, you know?
That's a nice idea. We should talk to Rick. Yes. Okay, and I'm not going to click the next link because it's a video on YouTube, so it will start immediately playing, but we have a new video in our community talk series on YouTube where we talk to Hector Ventura about how he developed Flossy, which is a tiny and very memory efficient AWS local emulator, which is now also expanded into, from what I remember, Azure, GCP, and I think there are more integrations on the way. And of course, he's using native image to make it so compact and small. And he talks about how he implemented it and how happy he is with his current stack. Now, in the spirit of AI, we as a project are accepting AI-assisted contributions. We have published some docs for you to sort of go through and realize how you can do it. Of course, we ask you to sort of still own the code and review it and sort of take a look at what your AI generated. But as a project, we are accepting the future and we are accepting those AI-assisted contributions. Just follow our guidelines for those contributions, please.
And thanks to those who are doing this already. The Quarkus team, for example, is doing this really well. So yeah, can make us more productive. We just need to use the AI tools the right way.
Yes. And speaking of frameworks, we also have two related framework updates related to our 25 release. So one is Micronaut 5 was released with a lot of features for GraalVM 25, but also for Oracle database. So if you happen to be using GraalVM and Oracle database, check out Micronaut 5. A lot of really good features there for you. And Quarkus, as we just mentioned, added a very nice support out of the box for running PGO. So as you know, normally PGO, what we call user-provided PGO, requires two steps where you do a training run and then you do an optimized run. And then they offer for you a nice integration where you can run your integration tests as this sort of profiling workload, and they will generate this profiling file for you, and you can just pick up and build an optimized native image. With that, a little bit over the time, I think we can slowly wrap up. If you have any question that you want to ask us, you can still have to do so in the chat. In the meantime, we will recommend to you to go and download immediately the new GraalVM 25.1 and give it a try. As always, your #1 place for all things GraalVM is here on the website. You can download, you can check the release notes, you can find ways to get in touch with us. Just go ahead and try it out.
And we should soon have that on SDKman too, but because this is our first innovation release and we changed the versioning a little bit and the file names a little bit, we need to make sure that all of this lands and propagates to SDKman very soon. There was one more question on WebImage, whether it will eventually support JavaFX. I don't see any technical problems that would make it impossible in the future, but right now, and that's maybe also a reason why we don't have any larger updates on WebImage right now. Some of the things that we need to support to make a JVM work is actually blocked by work on the WebAssembly side. So yeah, the JVM has very sophisticated threading support, and for example, which we need to make work. And there's a lot of other things too, like networking and other parts that we need to all make work with WASI, for example. But that's a large undertaking, and we haven't made enough progress to share an update there. But technically in the future, I think that should be possible. But like I said, we have a bigger fish to fry first. Then there is a question, it is already available in SDK Man. Oh, that's the question by Johan. I didn't read it, but I already answered that question, I guess.
Covered. Just give us some time. It takes time to propagate, but you can already get it from the website or from GitHub.
Yes, we know our users. We know what they ask. That's good. Is there any other questions in the chat? I don't see anything.
No, I think we are good for now. We see some things coming up. Okay, we need to go and then announce the release everywhere else to the rest of our users. Thank you so much for being with us. Give GraalVM 25.1 a try, and I guess we'll see you next month. Let's see.
See ya.
Bye.
Bye.